Okay, we are going to see, I think that the audio should be working now. I'm not going to go and completely reteach all of the notes just for the sake of time because I want to get this back out to you guys as soon as possible. But I am going to kind of go through what I have already written on to the note sheet and re-explain it just a little more briefly because the audio didn't work the first time. The one thing that we kind of relate types of error to are a courtroom and someone going on trial. So there is some type of truth. Either they're guilty or not guilty, and there is some decision that a jury makes, whether they believe they are guilty or not guilty based on evidence. And most of the time, you're making the correct decision. You are sending a innocent person to be free, or you are sending a guilty person to jail. And that is what you want to do. That is what you want to happen. And then there are cases where you make a mistake. And so an innocent person goes to jail or a guilty person goes free. And a lot of the time we potentially make those types of errors when we are running hypothesis tests in stats. Not as on such a high of a caliber in most cases, but it's just an analogy. One of the things that we often get asked is what mistake would be worse? And it really honestly depends on the situation. And it could be that maybe the crime is shoplifting and an innocent person going to jail is worse than a guilty person going free. And on the other hand, if it's murder, then a guilty person going free is a lot more problematic than an innocent person going to jail. An innocent person shouldn't go to jail, but you kind of get the idea. And those steps that we follow are very similar to things that we do in statistics. A jury is going to decide whether the defendant is guilty or not guilty, and we decide if we are going to reject or fail to reject a null hypothesis. And everything that we do when we first learned about hypothesis testing was we are doing it under the assumption that the null is true. And so under the assumption the null is true, we set up our sampling distribution, we calculate our probability, all based on what they are saying, and we are believing what they say to be true. Now, we collect evidence, we get a sample, we find a probability, and we see how likely is it for this event to happen. If it was pretty likely, cool, whatever they say goes. We believe what they are telling us. If it's very unlikely to happen, and it did, that's when we start to get suspicious and we decide that we have enough evidence to go against what they say. Now, what this relates to in terms of types of error, we have truth. We should either be sticking with the null and failing to reject it, or we should be rejecting the null and having evidence for the alternative. So there's some truth in the world. Most of the time, you are never going to actually know the truth. You are simply just doing your best with the evidence and the sample that you have. Now, you make a decision. You decide based on your p-value whether you are going to reject or fail to reject the null. And so that decision in two cases is going to be correct. When you reject and you're supposed to reject, and when you fail to reject and you were supposed to fail to reject. Those are cases where we're not super concerned. Those are the boxes where everything is okay. We say everything is fine and it works out. Now, there are cases where we kind of run into some issues where we decided to reject the null when we were supposed to fail to reject. So that is when we fall into type 1 error. And falling into type 1 error doesn't necessarily mean within the question that you are going to know that your decision is wrong. What we decide when it comes to types of error is solely based on the decision that you made. So if you reject, there is a chance you made a type 1 error. And if you fail to reject, there is a chance you made a type 2 error. And it's just with the nature of what your decision was. So it's not, again, that you are wrong. It's just with the decision that you made, this is potentially the type of error that you made. And the best way I can say to remember how to kind of keep these separate in your mind, I always go in and say that type 2 error is fail to reject. So anytime I'm looking at identifying what error I potentially made, if I failed to reject the null, it's a type 2 error. There is one other term that kind of falls into this category. We get into it a little bit later on, and that is going in and making the correct decision to reject, because that is the more interesting decision. And that is called the power of a test. So if you correctly reject the null, that is when you are identifying the power of the test. Now, we have a kind of fun an example of types of error. And so again, I'm not going to spend a ton of time just because this is like my third time trying to record this, and hopefully the sound is now working. But there is a very clear truth. The old man is not pregnant and the young woman is pregnant. And so there is a truth in each image. So the truth for the old man is you are not pregnant. For the young woman is you are pregnant. And there is a decision that is being made. So either they are deciding to tell the person that they are pregnant or not. And in two cases, they are making the right decision by telling the young woman she is pregnant and the old man he is not. Those are the correct decisions. That's the top right corner, and that is the bottom left corner that you are seeing. Now, the bottom left is you fail to reject the null because you were supposed to fail to reject the null. The null is true. We always say the null one is the dull one. Anything where the null is just going to be the same and the claim is correct isn't very exciting, which is why it doesn't get a fancy name. By telling the pregnant woman that she is pregnant, that is us correctly rejecting the null. So that is the power of the test. Now we go into the types of error. So for the top left, by telling the old man that he is pregnant, we are rejecting the null hypothesis. And this is solely based on this null and alternative at the very top of our paper. But the decision that we made was that we were deciding to reject. So by deciding to reject the null, that immediately is us potentially making a type 1 error, just based on the fact that we rejected. In the bottom right-hand corner, we tell a very clearly pregnant woman that she is not pregnant. That is us failing to reject the null, because we said the null is that you are not pregnant. So when we make the decision to fail to reject, that is us potentially making a type 2 error. Now, this last box just kind of has a brief summary of those three things: type 1, type 2, and power. Type 1, again, is rejecting HO, the null, incorrectly. Type 2 is failing to reject the HO incorrectly. So basically, based on your decision, it just ended up being wrong. Again, you're never going to truly know if you were right or wrong. It's just the nature of, this is the decision I made. This is a potential consequence of that decision. For type 1, it is always represented by alpha, because that is how likely you are to reject a null, because I will reject anything that is less than a significance level. So usually that's going to be given to you in the question, or it's going to be 0.05, which is our standard significance level. Type 2 error is represented by beta, and power is represented by 1 minus beta, because they kind of go hand in hand. One thing I will say, these are going to be values that will be given to you, at least for type 2 and power. They are not going to be things that you will have to find mathematically. Alpha is generally given, but again, it's something where if you don't have it, you just assume it to be 0.05. There is no value that we necessarily assume for type 2 or for power. And the last one being power is just the probability to reject the null correctly. So basically, you made the right decision. You told a pregnant woman that she was pregnant. So it's boring in the fact that you are doing the right thing, but you're rejecting the null still. So that's kind of what makes it exciting. Now, for their relationship with each other. So type 1 and type 2, they have an indirect relationship. Basically, as the probability of one increases, the probability of the other decreases. And that kind of goes hand in hand with rejecting and failing to reject. If my alpha is 0.05, that basically means I have a 0.05 chance of rejecting the null, meaning I have a 0.95 chance of not. And so if I increase that alpha, that type 1 error, naturally the type 2 error is going to decrease. Our type 1 error is set with our significance level. That's our alpha. The higher our significance level is, the lower our probability of failing to reject. So kind of just what we've been talking about, which is why they have that indirect relationship. The higher our significance level, the more likely we are to reject the null. Again, we kind of just were mentioning that. Therefore, type 1 error and power have a direct relationship. So if I increase my probability of type 1 error, which again is rejecting the null incorrectly, I am also increasing the power of a test, which is rejecting the null correctly. So again, that just kind of is increasing our probability of rejecting overall. Now, how do we actually interpret the error? It's not anything fancy. Really, it's just going to kind of fall back on that idea of what decision did you make. So a lot of the time they will ask you to interpret it in context, and they will ask you to list a consequence. So example 2 says a drug manufacturer claims that less than 10% of patients who take a new drug for treating gestational diabetes will experience nausea. So to test this claim, researchers conduct an experiment at the 5% significance level. So for A, I went ahead and wrote out our hypotheses. Remember, the null is always that it's equal to the claim. The alternative is what you think is happening. So they think it's less than the 10% that they are saying. Now, describe a type 1 and type 2 error in this setting. So remember, type 1 is you made the decision to reject. Type 2 is you made the decision to fail to reject. So all I'm going to do is relate that back to the hypotheses that I have listed. So we say less than 10% of patients experience nausea. So that's basically me rejecting the null, taking on the alternative, when really the null is true. So when really it is equal to 10%. Or a lot of the times they will sometimes accept you saying when my decision is incorrect or when it is not, but I still try to give as much context as possible. So that's why I went back to what the null is saying. And one issue that can happen with this is the manufacturer isn't going to fix the drug because they think it's working, because we made the decision to say that the alternative is true. For the type 2 error, we say 10% of patients experience nausea. So basically, we don't reject the null. We say the null is true, when really it is less than 10%. So really the drug is working, but I don't say that it's working. And an issue with this can be that the manufacturer is going to spend time fixing a drug when it isn't needed. And some of the follow-up questions for this tend to be things like, from the patient's point of view, what decision would be worse, or from the doctor's or the manufacturer's point of view, what would be worse. From the patient's point of view, it may be type 1 error because there is a drug that they are taking that isn't working. The other kind of point of view you can look at is the manufacturer, and for them, maybe a type 2 error is worse because they're wasting money trying to fix something that's already working, that they could be selling to patients that they're not making a profit off of. So a lot of this will be reasoning, and they tend to accept answers as long as it makes sense in the context of the question. So it's not like you have to say this specific language to get credit. It just has to make sense. Now, for part C and part D, the test has a power of 0.54. Again, that's a value that they're going to give you. And power is correctly rejecting the null. To detect that the alternative is true, explain what the power means in this setting. What is one way we can increase the power? So in this case, again, correctly rejecting the null, the probability we find that less than 10% of patients experience nausea correctly is 0.54. So basically the probability of us taking on the alternative and saying that the null is not true. And one way to increase power, which we mentioned earlier, was by increasing significance level. You technically can also say increasing type 1 error, because all of those things increase our chance of rejecting the null overall. Now for part D, you know that the power of this test is 5%, and the alternative against the alternative is 0.54. That's what we just got from part C. If you decide to use 0.01 instead of 5% with no other changes to the test, will the power increase or decrease? Well, if I'm going from 5%, which is 0.05, to 0.01, I'm decreasing my chance of rejecting the null. Therefore, the power is going to decrease because power depends solely on you correctly rejecting the null. So if the probability of rejecting overall goes down, your power of your test is going to go down because they have a direct relationship. Now, the last thing that kind of got covered in this set of notes was how inference testing and confidence intervals go hand in hand. So I went ahead for example 3 and I calculated both in the calculator. So a recent study suggested that 77% of teenagers have texted while driving. A random sample of 50 teenage drivers was taken and 33 admitted to texting while driving. Assume all conditions have been met. Use your calculator to answer the questions below. So we're not even going to check conditions. I solely went to the calculator. I went to stat test A for the 1 prop Z int, and I went to stat test 5 for the 1 prop Z test. So when you're actually writing this in the calculate section, you will formally name these tests. So like 1 sample Z test for proportions, 1 sample Z interval for proportions. But for this problem, we're just trying to relate these things together. And so from the calculator, I got my interval and I got my Z-score and my p-value. One thing within the stats tests for the 1 prop Z int, you do have to pick your alternative. And so the question itself is asking if it's different than 77%. So I picked the not equal to sign. So make sure that you are picking the right one. Otherwise, you're not going to get the correct p-value. So the one thing that we kind of relate for these types of things. So for the confidence interval, I went ahead and interpreted it with our kind of same prompt we've been using. We are 99% confident the interval from 0.4874 to 0.8326 captures the true proportion of teens who have texted while driving. And then for the 1 prop Z test, you always decide whether you are going to reject or fail to reject based on how your p-value relates to your alpha. So my p-value was 0.0646, which is greater than my alpha. So I'm going to fail to reject. So since the p-value of 0.0646 is greater than alpha equals 0.01, we fail to reject the null. There is not convincing evidence that the proportion of teens who text while driving is different than 77%. So kind of looking at those two conclusions, the confidence interval gave me plausible values for p. So somewhere between 0.4874 and 0.8326 is the true proportion of teens who text while driving. And the significance test said that 77%, the null, is a plausible value. And what you should see is if you cannot reject the null, so if in your hypothesis test you fail to reject, your interval should contain the null value. So 0.77 is within my interval, so these two tests end up agreeing. And sometimes they will give you questions where they only give you an interval and they ask you to make a decision on whether you agree or disagree with a claim. And all you have to do is go in and see, does my interval contain the value that they are asking me about? If it does, you have to agree with what they're saying. That's a possibility. You think that the null is true. If it doesn't, so if, say for instance, my claim was 0.32, 32 is not in my interval. So that would be a case where I would end up rejecting the null and I would not agree with what they're saying is true. So just to kind of show you how these work together, the level of confidence and the alpha level, the significance level, go hand in hand. They total up to 100%. So like a 90% goes with a 10%, a 95 goes with a 5, a 99 goes with a 1. And you're really just looking at, does your confidence interval contain the null hypothesis? If it does, you fail to reject. If it doesn't, you reject the null. So just to kind of show that in action, for example 4, Scott's Turf Lawn Builder makes the claim that when a user plants their grass seeds, 88% of seeds will germinate. They go on to plant 500 grass seeds, their fertilizer, and find that 412 of the seeds germinate. Assume all conditions are met. So what is the 95% confidence interval for this observation? So I went ahead, went to stat test 5. Yes, stat test 5. Let me double check. No, stat test A. Wrong calculator function. I went to stat test A. I got my confidence interval, and it was from 0.7906 to 0.8574. Now, because my interval, I'm looking at the value that they are kind of testing, and they write the null and the alternative within the question. They say 0.88. Because 0.88 is not inside of my confidence interval, and they're saying the null is P is equal to 0.088. That means there's no possibility of the null being true because it's not in the interval that I created. Based on my sample, I cannot agree. So because our confidence interval does not contain 0.88, we can reject the null. There is convincing evidence the germination rate of seeds is different than 0.88. So basically, we have enough evidence to say the null is not true. We are going to take on the alternative. Now, for part C, it says find the p-value for the test. This was stat test 5. Explain what the p-value measures in the context of the problem. This is not a question of do you reject or do you fail to reject? This is an interpret the p-value. So what does that 0.0001 represent? And it's always under the assumption the null is true. So that's the first thing I always write, assuming that the proportion of seeds that germinate is 0.88. The claim that they are saying is true. There is a 0.0001 probability of getting a sample proportion at least as extreme as my p-hat, which is 0.824, and a sample size of 500 grass seeds due to random chance. And this is one of the last prompts that we looked at in 7.2 if you want to kind of look at the typed up sentence, but really all you're plugging in is the null, your p-value, your p-hat, and your sample size. And that is how you go on interpreting a p-value.